Hello, grade 10s. So let's give this a go. We're going to take a look at our third way of solving linear systems. We looked at two ways already. First one was using graphing, so we graph two or more lines in the same grid, find their point of intersection. I looked at a more algebraic method, which was called substitution. So the last way we're going to look at is called elimination. Before we get too much into it, let's take a look at this situation right here. So essentially we have two different Starbucks orders. So the first one has 3 grande and 2 tall coffees, and with a total of $7.75. Then a different order of 3 grande and 5 tall, and that total comes to $11.95. And we're just trying to figure out how much each of these coffees costs. So the first thing you might want to do is to try and set up equations for this. So if you let G be the price of a grande coffee and T be the price of a tall coffee, you can get two equations that look something like this. So we've got 3G plus 2T being 7.75, and 3G plus 5T equals 11.95. So one thing I want you to notice if you look at both of these equations is that each of these orders, each of these equations has 3G or 3 grande in it. The only difference in the two orders comes from the fact that we have 2 tall coffees in one of them and 5 tall coffees in the other. So the difference in price from $7.75 to $11.95 only comes from those extra 3 tall coffees. So the way you could simplify this a lot if you're trying to solve for both of these prices, so you could say that those extra 3 tall coffees will account for that difference in price from $7.75 to $11.95, which is $4.20. Okay, so once you have that written out, once you know that those extra 3 tall coffees is what makes up for that difference in price of $4.20, then you can solve for the price of the tall coffee. You divide both sides of that equation by 3, and you get $1.40 for the price of a tall coffee. And just as in substitution, once we have that price or that value of one variable, we can now substitute it into the other equation, or one of the original equations, to try and find what the price of the other one is. You can use whatever equation you like. You sub in the t equals 1.40 into it, and then you can solve for g. So once you go through that algebra there, you'll find that you have a price for a grande of $1.65. So in essence, this is elimination. We're going to work on it a bit more formally coming up, but this is the whole idea behind it. Okay, so let's take a look at our next example here. Now this one here, before again we get too far into elimination, I want you to try and solve this one using substitution. Try it on your own, pause the video, and when you're finished, let's just check our answers. Okay, so taking a look at what we have here, again, just to quickly go over the steps, what you want to do with substitution is choose a variable to isolate in either equation. So I personally chose to isolate x in the first equation. So going through that process, we went to x equals 1 over 3 minus y, so we can do some fractions into the question. And then once we do that, once we have variable isolated, we take the other equation down here, this is equation number 2, and we substitute the x equals 1 over 3 minus y, replacing it into the other equation here. So once we go through this, we have an equation with just y's. We use some algebra, expand, simplify, collect your like terms, solve for y. Then you can use one of the original equations, replacing y in the other one, and solving for x. You wind up with a point of intersection of x being negative 2 over 3, y being 1. So if you compare this question to previous ones you've done with substitution, you want to think about what made this one maybe a bit more complicated to solve compared to some of the other ones. You'll notice here that if you look at the original equations, there was no variable we could choose to isolate for that wouldn't have introduced fractions. So before, if we had an equation with a variable with a coefficient of 1 or negative 1, we could isolate for that nicely, substitute on the other equation, and then basically hold off working with fractions as long as we possibly could. Here we don't have that choice. Fractions get introduced right off the bat, and then we have to work with them throughout. It doesn't make the question impossible, it just makes it a little bit more challenging. Okay, so given that it was a bit more challenging using substitution, let's try and use this new elimination method to go through this exact same problem and see how much faster it can be to get to the final answer. So taking a look at this one, it's the exact same problem. What I want you to notice again is if you look at both of these equations, they both have a 3x in them. Okay, so accounting for the difference in the constant over here, those x's aren't doing anything, it's just a difference in y's. So what we can actually do is look at both of these equations, they both have 3x in them. We can actually subtract those equations. So I can take my x values and subtract them, my y values and subtract them, my constants and subtract them, and create a brand new equation that might potentially be easier to solve. let's see what happens when we do this. So if I take the first equation, subtract the second equation, looking at my x values first, I have 3x minus 3x. 3x minus 3x is 0x, so those x's have now been removed or eliminated from our new equation. So that helps, having the x's gone. Now let's take a look what happens when we subtract the y's. We have 3y minus negative 4y. 3y minus negative 4y is the same thing as 3y plus 4y, so that gives us 7y here. Okay, if we take a look at our constants, we have 1 minus negative 6. 1 minus negative 6 gives us 7. So with one sort of simple step of subtracting those equations, all of a sudden our x's are gone, and what's left over here is much, much easier to solve. We just wind up with 7y equals 7, which gives a solution of y equals 1. Okay, and just like before, now that we have one variable solved, we can go back to one of our original equations. Again, we can choose whichever one we like, the first one or the second one. I'll choose the first one only because there's no negatives in it. Might make it a little bit easier on myself. So if I take a look at that original equation, so that 3x plus 3y equals 1, and then I can take my y value, substitute it in there, so I wind up with 3x plus 3 times 1 equals 1, and then I can do some algebra here to solve for x. So I'd wind up with 3x equals negative 2, so then I wind up with x equals negative 2 over 3, so I wind up with the exact same solution I did before, but you can see here the algebra is a lot easier once we've used elimination and gotten rid of those variables from the start. Okay, so let's just move on for now. So what you have here is two different systems, and we're just going to try and apply elimination to each of these. We're not necessarily going to go through the whole solution. I just want you to think about looking at each of these systems of equations. Number one, which variable are you going to want to eliminate, x or y? Whether you'd want to add or subtract the equations to eliminate the variable, and the new simplified equation you get after you add or subtract. So looking at the first one here, we've got 3x minus 3y equals 6, 2x plus 3y equals 14. Right now, looking at this, you can't eliminate x, right? If you add the two equations, we have 3x plus 2x, it'll give us 5x, so the x's are still there. Same thing if we subtract. We have 3x minus 2x, there's still an x hanging around. So right now, we can't eliminate x with this. Let's take a look at y. So if we were to subtract the equations, we'd have negative 3y minus 3y, which gives us negative 6y. Again, nothing's been eliminated. However, if we were to add these two equations, we'd have negative 3y plus 3y, which would give me 0y over here, and all of a sudden we've eliminated one of the variables, in this case y. So here we're going to eliminate y, okay, and we're going to do it by adding. So once we add again, negative 3y plus 3y gives me 0y, those y's are gone. We have 3x plus 2x to give me 5x, and then over here for my constant, 6 plus 14 equals 20. So by adding these two equations, I've eliminated y, and I have a new simplified equation of 5x equals 20, and I can move on and solve from there. Okay, I'd like you to take a look at the second system over here now. Try it on your own, see what you'd want to eliminate. Pause the video and press play when you're ready to see the answer. Okay, so for the second one, you want to eliminate x here because we have 7x and 7x here. It's the same coefficient. They're both positive 7 here, but if one was negative, we could still eliminate the x's. And then we want to subtract the equations in order to get them to go away, because you'd have 7x minus 7x to give us 0x, and the x's are eliminated. So subtracting the y's, negative 2y minus negative 5y gives us 3y. 19 minus negative 7 gives us 26, and we could continue on and solve the rest of the equation from there. So in general here, when should you add the equations, when should you subtract the equations? Here you'll notice that we added the equations when the signs on the variable that we wanted to eliminate were opposite each other. We had negative and a positive. We add them, they eliminate each other. And here we subtracted when the coefficients were the same sign. So you should add the equations when the sign is opposite and subtract them when they have the same sign. Okay, so let's take a look at another example here. Now one thing you'll notice here, that if you're looking at this system here, none of these variables have the same coefficients in either the equations. So before we either had, if this was 3x, this would be positive, or a negative 3x we could eliminate, or something similar would happen with the y. So we could just do a simple adding or subtracting of the equations to eliminate a variable. We can't do that here. So I want you guys to think about here is if we want to use elimination here, what could we do to these equations to try and allow ourselves to use elimination? So take a minute and think through that one. Okay, so hopefully you've thought about that for a minute. So one thing I want you to take a look at here, if we have an equation here, let's say we have 3x plus 2y equals 2. I'm going to quickly open Desmos here and graph that one so you can have an idea of what it looks like. So 3x plus 2y equals 2. Okay, and we get a line right here. Now, I want to see what happens if we just take that entire equation and multiply it by something. So, you know, picking a number at random, let's say we choose 5. We multiply this entire equation by 5. So what we're going to wind up here is 3x times 5 to give us 15x, 2y times 5 to give us 10y, and 2 times 5 to give us 10. So you'll notice here that it creates the exact same graph. So by multiplying that entire equation by a constant, we haven't actually changed our line. So going back here, we can multiply one or both of these equations by whatever constant we want. Now if we're strategic about this, we can take the first equation and multiply it by 2. Okay, so if we take that equation and multiply it by 2, that's going to give me 6x here, 4y here, and 4 over here. So if I have a 6x here, and let's see if I can use the second equation and get a 6x as well. And hopefully you can see if I take this equation and multiply it by 3, then I can try and create a 6x there, which will help me use elimination. So multiplying this equation by 3, I get 6x here. Minus 3y times 3 gives me minus 9y. And then 4 times 3 gives me 12. Okay, so what this allows me to do now I have a coefficient of 6 on both those x's, and now I can use elimination. Okay, so just for reference sake, I'm just going to renumber these equations. I'll call this one equation 3, this one equation 4. And now, since I have 6x here and 6x here, if I take these equations and subtract them, I should eliminate x. Okay, so what's going to happen here is when I go 6x minus 6x, those x's have been eliminated. If I do 4y minus negative 9y, that will give me 13y. And then I have 4 minus 12 to give me negative 8. And so if I solve that for y, I get y equals negative 8 over 13. Okay, so now just like before, you need to throw it into one of the original equations, substitute the y in, and solve for x. So take a minute and try that, pause it, and push play when you're ready to see the answer. Okay, so again, you can choose whatever equation you like. If you choose the first one, you're going to be putting the y value of negative 8 over 13 into here. Okay, and when you go through the algebra here, you have to work with some fractions here, but you wind up with a final answer of x being 14 over 13. So you get a point of intersection, x equals 14 over 13, y equals negative 8 over 13. Okay, so from here I'd like you to try the next example on your own. The rest of this lesson will be continued in the next video. Thanks.